Alright, welcome back. Let's now talk about that rate limiting step proper. Let's go into it in a bit detail. Okay, we understand that we have glucose forming glucose 6-phosphate. Are you there with me? Then giving rise to fructose 6-phosphate. Is that also? Then here we then produce fructose 1,6-bis-phosphate. Is that also? Alright, now the idea is this: the enzyme that is catalyzing this step is the PFK1. Now this enzyme is the rate limiting step of glycolytic pathway. So one of the things that we activate this enzyme, we've already discussed, is AMP. But the most important one is what we call fructose 2,6-bisphosphate. So there's an enzyme here that has the ability to convert fructose 6-phosphate to fructose 2,6-bisphosphate. So instead of putting the phosphate at carbon 1 like we did for this one, we put it at carbon 2. So just imagine for a minute that we have 10 molecules of fructose 6-phosphate that are undergoing glycolysis. If the cell is wise, you know what the cell will do? The cell will sacrifice one to form fructose 2,6-bisphosphate. Then the remaining 9 will go and form fructose 1,6-bisphosphate. Now when you sacrifice that one to form fructose 2,6-bisphosphate, this fructose 2,6-bisphosphate will now stimulate this enzyme more. So any other further glucose that is coming in will be stimulated faster. Do you understand what I'm just saying? I'm saying that as a way to stimulate this enzyme more, the cell sacrifice some amount of fructose 6-phosphate to form fructose 2,6-bisphosphate. So that if you form fructose 2,6-bisphosphate, it will act as a powerful stimulator for this enzyme. That's why I made mention that this substrate here is very, 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 very powerful when it comes to stimulating PFK1. Now the question now is, which enzyme actually forms this fructose 2,6-bisphosphate? Fructose 2,6-bisphosphate is formed by an enzyme that is called PFK2. Why is it called PFK2? Because it phosphorylated at carbon 2. I believe you now know why this one is called PFK1, because it phosphorylated at carbon 1. So PFK2 now is the enzyme that is responsible for forming fructose 2,6-bisphosphate, which is a very, very powerful stimulator of PFK1. But there's something about PFK2 that I will just want to put here, and that is the fact that it is a bifunctional enzyme. So imagine here is PFK2. Imagine we have PFK2 here. PFK. Okay, let me use the white color. Imagine we have PFK2 here. PFK2. Sometimes PFK2 can have the ability to phosphorylate. Other time it can become a phosphatase. That is to say, it can remove phosphate. Now, what determines whether PFK2 will phosphorylate or do the opposite, that is to say remove phosphate, is the presence of hormones. So if in the presence of glucagon, PFK2 will become phosphorylated. This PFK2 will become phosphorylated and do not form PFK2 phosphorylated. Or there's another name for it though. It's also called, okay, for simplicity's sake, it will now form the phosphorylated form of PFK2. And this phosphorylated form of PFK2 is inactive, meaning it cannot form, meaning the levels of fructose 2,6-bisphosphate that is going to form will be what? Will be low. And if you have low levels of fructose 2,6 bisphosphate, will you be able to activate glycolysis? No. What am I trying to explain in this entire diagram? I'm trying to tell you that yes, everybody is aware now that PFK2 is responsible for forming fructose 2,6 bisphosphate, but it's not always true. Sometimes if that PFK2 is phosphorylated, like we have in this diagram now, in this phosphorylated form, which is done by the presence of glucagon, it will become inhibited and cannot form a cannot form a fructose 2,6 bisphosphate for you, so you cannot favor glycolysis. That's why glucagon inhibit glycolysis. On the other hand, if insulin is present, this phosphorylated form will become the phosphate will be lost. So the phosphate will be lost from the enzyme. Are you there with me? So we'll now have it as the form that is not having phosphate. This one now will now be responsible for forming what? Fructose 2,6 bisphosphate. And this one will now activate what? Will now increase what? Glycolytic pathway by stimulating that rate limiting enzyme. This one will decrease glycolytic pathway. This thing appears a little bit complex, but it's just a concept. It's just a concept. Now, I want you guys to actually grab this thing. That's why I say I want to do it in a separate video. So the thing is this: we have fructose 1,6 bisphosphate, right? Sorry, all of us are familiar with the fact that PFK2 is responsible for forming fructose 2,6 bisphosphate, which is a very powerful activator of glycolytic pathway. Is that not so? Because it will stimulate this rate limiting enzyme here. Is that not so? Right? Now I'm just telling you now that PFK2 is not always activated. In the presence of glucagon, it becomes inhibited, that is, it becomes phosphorylated. Are you there with me? And this phosphorylated form cannot form this our very powerful activator of glycolysis. You understand? Meaning, in the phosphorylated form of this enzyme, it becomes inhibited. But in the presence of insulin, this phosphate will be lost. Then this PFK2 will become more activated. Then we can now form more of fructose 2,6 bisphosphate, which will now stimulate glycolysis. Simple. I don't want to complicate it further. That is, you just have to watch the video, watch it over and over, then you get the concept. In summary, let me simplify this thing for you again a little bit. Just if you can't remember this thing, just know that first that fructose 2,6 bisphosphate is a very powerful activator of glycolysis. If you are okay with this, then there's no problem, but you can revise back to understand this whole concept. Okay, now let's now move to the fate of pyruvate. In the next video.